two more minutes. 1.5 minutes.
Is this water drinkable?
Yes.
It is for us.
It is for you. Good. All right. Good afternoon, everyone, and greetings to the online audience from wherever you're watching from. Welcome to this very timely panel on generative AI at the World Economic Forum annual meeting of the new champions in Tianjin in China. Today we gather here to explore the profound impact of generative AI on our society and the limitless possibilities that it holds for the future. As we embark on this transformative journey, it's crucial for everyone to understand the potential, the enormous potential that we see with this novel technology, but also the challenges and the responsibilities that come with it. Today we have the privilege of hosting a distinguished panel of thought leaders, experts, and visionaries. And they're here to answer many of your questions on the challenges and opportunities brought by generative AI. Hopefully by the end of the session, through their collective wisdom, that we have a better idea in terms of how generative AI can be used as a force for good, a catalyst for innovation, for creativity, and also for human progress. My name is Kathy Lee. I'm the head of AI, data, and metaverse at the World Economic Forum. First of all, let me introduce our distinguished panelists. On my immediate left, we have Minister Emily Stoimanova, Minister of Digital Transformation of Slovenia. Welcome. Then to her left, we have Zhang Yaqin, Chair Professor, Tsinghua University, Dean of Institute for AI Industry Research. Then we have Pascal Fang, Chair Professor at the Department of Electronic and Computer Engineering at the Hong Kong University of Science and Technology, also Director, Center for AI Research. To Pascal's left, we have Chen Xudong, Chairman and General Manager, IBM Greater China. Then we have Wang Guan, co-founder of Learnable AI, Director of Intelligent Finance Lab of Shanghai Jiaotong University, Ningbo Institute. Welcome, everyone. It's an honor and pleasure to be here with all of you. Before we get started, very quickly, just some quick housekeeping items. If you are keen to share your experience with your social media channels, the hashtag is AMNC23. So let's jump in. But before we get started, I think, first of all, we need to ask the question, what is generative AI? And I'm looking at Pascal. If you can just give everyone an overview in terms of what is the technology, what can it do? That would be great.
So originally the term generative AI is to say that it's an AI system that generates content, whether it's text or image. It is different from, say, classifier, which gives you the label of something when it sees an image, or whether it gives you a prediction of some number when it sees some content. But today's generative AI is different from previous generations of generative AI systems in that these are large models. So you've heard of large language models for text content. You've also heard of diffusion models for image content. So these are huge models that have been trained from everything on the internet, whether it's image or whether it's in even video or text. And they have a huge parameter size. So these are humongous neural networks. And they were not actually trained specifically to do any specific task. They were just trained to generate the content as a kind of a pseudo task. But what we have discovered is that when these models reach a certain size and parameter size, we have seen that they're able to perform many different tasks that they were not specifically trained on. So this means that these generative models are especially powerful because we can use them for a multitude of tasks in AI, and we can use them to build other types of AI systems downstream. So this is why these models are very, very powerful, and in fact, they're very creative because they're generative. Of course, they also come with the downsides, and I'm sure we'll talk about that later.
Thanks, Pascal. So it is a general purpose technology, and in that case, usually industries are the first ones to, adopt, but also to utilize it. So I wonder, Xudong, if you could speak to, in terms of, for example, IBM, how does IBM leverage the technology for your own operations, but also work with other players in the industry?
OK， 我用中文来讲哈，这个
So I'll be speaking in Chinese. Actually, IBM started looking at AI in 1956. So for the last decade, IBM has made some very important contributions, including in 1997, our computer won an important award, Deep Blue Award. So when it was until AI started to learn to play chess that people started to notice AI. And today, we have an AI strategy in IBM. We rely highly on AI. So we have two types of products. The first type is targeted businesses. I believe you've already heard of Watson. Watson X is our latest version. So this is our new product in the era of generative AI. So that is the first type. Our second type is that in our software product, it also is AI is also integrated. Also, for process automation services products, we also have AI integrated. Also, for our mainframe system, today we have already integrated AI in our mainframe systems because during in all transactions in banks, we really need AI to help us safeguard the bank system. So in our internal operation, we're also using artificial intelligence. So in our company, we have a chatbot. If you have any question, you can also ask our internal chatbot. So you can see that throughout our operations, we're heavily using artificial intelligence.
How to leverage those technology, usually much faster than others. But I'm going to turn to the minister. As a policymaker, what are your hopes and fears when it comes to when you see the industries are adopting the technology at much faster speed a lot of the times compared to the government? What do you think, even when it comes to, for example, protecting the industries against certain risks, let it be operational, business, or from cyber perspective, what are the things as a policymaker that you're wishing to see that's happening?
Thanks for the question. So, of course, there are fears, but I believe that the fears should not hinder the innovation that is, because AI brings huge potential. And if we speak all the time about the fears, then we might lose this potential. And this is not what I would like to happen, also as somebody coming from the government. I believe that generative AI can really boost innovation, and I would like to see that in the government as well. So just now in our Slovenian government, you mentioned the chatbots at IBM. We are introducing new ways of communication with our citizens. So we're establishing new channels of communication where we would like to use generative AI. And I see huge potential. So what are my concerns, not fears, is the competences of the public servants, then the competences also of the citizens. Then my concern is to introduce AI into schools, the generative AI into schools. Why? Because I'm not quite sure whether the teachers know how to use, whether they understand what generative AI means, how it can be used, what are the fears behind. So these are usually my main concerns. And the biggest one is the biases. Because we already have the stereotypes and the biases in the world existing, and the AI can even increase those biases. So we need to find a way how to eliminate the stereotypes and the biases and to make sure that they will not cause additional divides in our communities.
Speaking of education, it's a perfect segue to Wang Guan. Tell us about Learnable AI. What does it do? What does it have to do with education as well?
Oh, thank you for the opportunity. So we started Learnable from Harvard Innovation Lab back to 2017. And we actually were doing large language models, but without calling it large language models. We were calling it cognitive intelligence. So we realized that targeting a niche market is actually better for startups, because generative, like general model, is actually very expensive. So we choose education because we believe that AI can replace a lot of human labor, like both physically and also mentally. So I believe that teaching is not simply, cannot be simply replaced, because the interaction between students and teachers, there's emotion inside. But the grading of the students' homework, exam problems, and tutoring can be done by AI in a very amazing way. Actually, after, I believe, 6 years research and development, our product's actually much more mature. And for this year, we have successfully applied it in the National College Entrance Exam in China, and also the High School Entrance Exam in China. So after AI become mature, it is actually more productive than human labor. It is cheaper, it is faster, and it can offer much larger scale than the human labor. So during the COVID pandemic, there are a lot of schools facing lockdown. The students are forced to go home, and that caused big trouble to their parents. It can be solvable by offering a phone or tablet, or just through videos, the teachers can teach the students. But when they have to do their homework, how can the parents solve the problem? So for us, it's very simple, like take a photo, all the rest can be done by AI. So the students can know what is right, what is wrong, why it's wrong, and how to improve. So we believe such technology can kind of mitigate the gap between the wealthy family and the poor family. Because after the models mature, the cost for offering a new service to a new client is very low. So as a small startup, we are Series B, we believe that this is actually a good opportunity for little company like us, not competing directly with big players like OpenAI. On the other side, for educational problems, you cannot make mistakes. Like if you ask OpenAI 100 questions, it can answer 60 of them perfectly, and 30 of them okay, and 10 of them probably wrong. But that is not acceptable for education. So once we fine-tune and retrain our model to be super good, it gives us a very strong competitive power. So that's what we do for today. And actually, we recently opened our API to all the educational players. So we want to be the fundamental supporters for any education companies, schools, teachers, tutors, and parents to make sure they can accept very cheap but good services.
Indeed, specialized data seems to be, have a competitive edge when it comes to the general purpose use language model. I do want to come back to that, especially I can relate to, your point on getting through the national exam. I think many of the, participants here in the room can relate to that as well as part of our childhood memory. But before we do that, I wanted to turn to Yaqin. You are an industry veteran with your experience with Baidu and Microsoft, and now you are working at Tsinghua University. Can you tell us a bit more about, in particular, the generative AI landscape in China?
Well, it's quite interesting. We had a similar panel just about 7 years ago in Davos, winter Davos, and also here in China. The whole technology has just completely transformed the industry, including in China. I talk about China a bit more. I spend 1 minute. Just want to summarize, my observation when I look at, ChatGPT or Stable Diffusion in the last couple of years. So my first observation was to say, wow, this is the first software actually passed Turing test. For computer scientists, this has been a major endeavor, right, to develop something that can pass Turing tests. And so this is the first conversational AI software that passed Turing test. The second thing, to Pascal's point, that this actually leads to AGI. Right? It's not exactly AGI yet, but it does provide the AI a pathway towards artificial and general intelligence. That is another goal that we've been trying to pursue. The third thing I think is probably more important. You asked about industry, and I consider this as a operating system for AI. And back in the PC days, we had Windows and Linux, and in the mobile days, we had iOS and Android. So this is the new operating system for the era of AI. So we'll completely reshape the whole ecosystem, whether it's the silicons or the application ecosystem. For example, Professor Wang just talked about education. That is actually a vertical model based on the large operating system, the language model. The data he used to train the exams, it's not the data that used for training the GPTs. But that really works out because you can have an operating system that is large language model, and you're going to have a number of vertical models that for different industries. Then you have application on top of that. So the industry will be very, very different. All the apps and all the models will be has to be rewritten, has to be completely restructured. So this is so in China. If you look at all those years, China has been doing just some terrific work in basic research, in algorithms, in industry applications, in every sector. And obviously, ChatGPT was not invented in China. We still talk about that. But just in the last 6 months or so, there are almost 100 companies, new companies, in the generative AI space. Some of those are large models, and others are in the generative AI for the vertical models, to generate not only in language but also the images and the videos. And I'll talk more on the other space, in the robotics, and also in the biological computing space. So just tremendous activities going on in China. And Professor Wang's company is just one of them.
Indeed, currently most of the large language models are in the US, in China, some are in Europe as well. It does look like it's a paradigm shift, and we're looking at generative AI, large language models potentially becoming the next public-facing internet infrastructure. So it does have huge impact on the society. But I wanted to go back to Pascal. At the end of April, US co-chair with the forum, we co-hosted a responsible AI leadership summit where we convened, some of the most prominent AI researchers in the world, and we discussed extensively about the guardrails that need to be put in place. And you spoke, it was fascinating to hear some of the, surprising emergent properties that you see from large language models, and how do we put some of the guardrails in place? Can you elaborate a bit, please?
Yes, indeed. Actually, Yaqing was also invited, but you couldn't make it. So yes, I think, so I have been in conversational AI research for close to 30 years. And I think people in my area, we share this common excitement and also surprise. So a few years ago, we talked about the fourth industrial revolution. And that was when AI was taking off. But today, I believe, along with some of my peers, that we are seeing a revolution that's beyond industrial revolution. It is perhaps another, quantum jump in human civilization. I am not somebody who like to, hype about AI. Quite the contrary, since I've been in this area for so long. But fundamentally, these models are very different from anything we have seen before because we did not develop them to do what they are doing today. We sort of discover this amazing architecture, and we stumble upon this. I shouldn't say stumble upon. A lot of people work on it. But if you talk to the leading neural network inventors such as Yoshua Bengio, they will tell you they never expected it to manifest. These models, the neural network models, to manifest this kind of capabilities. So we feel that we have, for the first time, have discovered, not really built, but discover a form of intelligence, in this case machine intelligence, that's comparable in terms of performance. I should emphasize that. In terms of task performance, it's comparable to human performance in many tasks. In many other tasks, they actually surpass human performance. So again, machine intelligence, they are nothing if you don't prompt them. Okay? That's the difference between machine intelligence and human intelligence. Humans don't prompt these machines, they don't do anything. Whereas a human being, if you don't talk to me, I'm alone, sitting alone in a cave, even for like 10 days meditating, I am an intelligent being. I have internal, emotional life and internal turmoil and so on. But machine intelligence is not like that. They perform the tasks, in cognitive tasks at the human level, but they don't have this kind of inner, I would say inner mental state or inner workings. So that's a very big difference. But since we have discovered such intelligence, we need to work with them, right? We need to learn to work with them. Even the people who build these systems, we don't actually know the extent to which what their capabilities are. So my team recently did a benchmarking paper on ChatGPT. So we used about 23 standard, publicly available benchmarking test sets to evaluate ChatGPT in the standard natural language processing tasks, from machine translation to summarization and so on. And I believe that was the first third-party benchmarking paper on ChatGPT, since OpenAI didn't publish their benchmarking at the time. So we did that. And so it's a process of discovery, right? And discovering both the abilities of these models and discovering how we can work with them. So I think this is why we are all very excited. And we are cautiously optimistic. I understand the fear from the general public. And I think this fear from human being is very natural. It's related to our survival instinct. It's like when people see, about a decade ago, a CGI simulation of actors, human actors. And you see, we know this phenomenon called uncanny valley. If you see some simulation of humans look very close to human, but not quite, then it triggers some fear in us. And scientists say that is, because of our own survival instinct. And today we're seeing the uncanny valley of these generative models. They're performing tasks. When you interact with them, they are answering questions, or they are interacting with you, telling you things like a very intelligent human being. And that triggers, of course, excitement, and of course, also fear. So this fear is natural. We need to recognize that. But like the minister just said, we should not let it stand in the way of progress. On the contrary, we need to actually develop more guardrails. We need to work. So again, with all these leaders in San Francisco, we discuss about a framework for developing responsible generative AI models, and not just adding safety layers and not just having human in the loop, but fundamentally understand these models and to have it align with what we human want at the database level, training level, and also at the generation step, so that it is more like a partner to us rather than enemy. I don't think they're enemies,
Yeah.
And so this is my view.
Yeah. So to summarize, is it fair to say that the fear about any novel technology is not so much about the technology, the machine gains consciousness, but it's the same way as technology can be used for good or for bad. So it's more about how do you actually leverage it. So on that note, Xudong, I wonder, from business perspective, how do you, again, both for IBM, but also with the clients and other industry players that you work with, what's your advice in terms of protecting themselves against the potential risks? For example, cybersecurity, privacy, and IP protection, because right now the reality is we don't know what are some of the data sets that's gone into training the large language models. Would you have any advice on that?
对，关于这个 AI 可能产生的
Well, on the potential risks from AI, IBM has been working on this for a long time, and possibly for the longest time. And we also abandoned research on facial recognition because there's too much potential for abuse of that. So after ChatGPT became popular, IBM released a product called What's on X, which helps companies to look at their own AI process. Now, firstly, What's on X sorts out their historic data. The second part of it is What's on X AI, which takes data from the set and puts it into both open source and proprietary IBM models to see what is possible, with training, optimization, and deployment. And third step, going back to the question that you've asked, watsonx.governance. Now that's the third part of it. It helps you in every stage to ensure data and information security, because that's what a lot of people are really worried about. And so we need to make sure that when you're going through this process, it's also fully compliant and legal. So that's something that allows companies to set up their own internal AI capacity. And apart from that, we have also been working on other things. Every company will assume that their own AI models will never be as big as those big models out there. So we're looking at ways to integrate internal AI models with the big models. And an interesting possibility is using big models to train company models. We call it DABI, literally big white and little black. So we get big white to train little black. It has very interesting results. That's the last few years of our experience. So we allow companies like that to improve their own capacity by means of AI.
You use.
When we started to train our own model, there was no larger enough language model for us to use. Yeah. So when we first started, we were facing a super challenging problem, which is still very challenging for even GPT. Like if you give him a mathematical problem, and you want it to be 100% accurate, you don't want it to make any mistakes, and you also want it to be able to do logical reasoning. We realized that with very limited resources as a startup, it's just not an easy deal. So we actually have learned a lot from earlier players, MATLAB, Mathematica, and we learn a lot from existing classical approaches. And in the very end, we mix them together and make sure one thing works. So we actually envy a bit for the followers because they now have much more powerful tools. But for us, those are the dark ages we have to go through alone. So, but for today, when we realized that people started to realize, hey, AI model can handle these things, the population is somehow educated, taught that they believe this is possible. There were a very long time that when we tell people our model can do the grading and tutoring, they thought we were liars until they actually tried our own product. So I believe in the future, OpenAI actually invested in a robot company called 1X. One of the co-founders is a good friend of mine. So there will be a day when robot and real human beings look super similar. And when that day comes, I believe most educational tasks can be 100% totally done by AI. But that probably comes in like 20 years or even 30 years. As for today, we focus on very small question, but very challenging question, so that even if the other big players, they realize this is a big opportunity, but it will take them 3 to 5 years to chase where we are. So I think that's the surviving approach for small startups. Yeah.
I'm not sure if I want my tutor to look like AI tutor to look like human, but I'll take the accuracy, that's for sure. So again, back to the guardrails question, Minister. A lot of the immediate impact on, that come from AI is on jobs. As policymakers, what are your thoughts on that? How do you prepare for future where AI could impact on jobs significantly?
The only constant thing in life are changes. And we all need to be aware of that. So technologies are changing the job market. It was the automatization first, now it's the AI. And I always like to say that once we finish with university, it's not the time when we stop learning. But we need to continue with the learning all the time. And this is something that the government needs to understand. It's something that the companies need to understand, the researchers, so to continuously update their programs, but also all the individuals. So what the government can do, okay, it takes some time to change the study programs. Of course, it's not immediate. You can reskill and upskill your workers in a shorter way. And sometimes you just need to be patient to make sure that you make all these changes. So again, there is a fear that AI will take our jobs. Yes, but it will create new jobs. So maybe we should see this as a potential. What are the new jobs that will be created and how we can approach to those new jobs?
Yeah, absolutely. I recall seeing a research, a survey, a poll somewhere that China definitely, as general public, definitely has more optimistic attitude towards AI compared to the rest of the world. I do think that has something to do with the population being, I think, significantly more digital savvy, and probably a good understanding of the technology, but we'll see what happens in the future. Yaqin, I wanted to go back to you. In your new capacity as a professor at Tsinghua University and also the Dean of Institute for AI Industry Research, can you elaborate how your research has integrated and incorporated generative AI, and what are some of the significant outcomes so far that you're allowed to share?
Yeah. I started this lab when I retired from Baidu about 3 years ago. So, we obviously doing basic research, but a lot of our work is to apply this research into real problems. So, we use generative AI in almost everything we do. I'll give you a couple examples. One of our research focus is on robotics and autonomous driving. Obviously, you need to collect a lot of data, right? We actually, I work with Baidu Apollo. We have hundreds of cars that actually driving around in China and collect a lot of data. And also we have robots that collect data. but those data are still very small compared with the kind of data you need. So one thing we do is we use generative AI to augment some of this data.
Yeah.
And also we use generative AI to do simulation. Because there's a dilemma. When you put a car in the street, you want to avoid accidents. Right? But it is the accidents you're trying to minimize with your training and with your algorithms. So you don't have those data. Right? So what happened with stable diffusion, things we use, and the nerve, is to actually generate those long tail cases. That's been super helpful. And also allow us to do the connectivity, end-to-end connectivity from the real scenario to simulation, and simulation back to real scenario. So I call it RSR. So that is one example. The second example is in the biological computing. That's one of our major efforts. We built a GPT, we call it Biomat GPT. That is very similar to education, but this one is for biological and the medical space. It is not it's not a trillion parameters. It has a little bit over. One has a light model, 1 billion. The other is 10 billion models. So what happens? You use data, the omics data from protein structure, molecule structure, cells, and genetic structure, but also using literature, the patent data. Use those as the training set, and then obviously you to the GPT, you have a big model. The good thing about this is once you have this model, you can to generate downstream tasks quite easily. And for example, protein structure prediction and generation, molecular docking and binding structure. You can do a lot of things just with that one particular model. And a lot more. We have people work on multi-model, large model, which this is the next step. And also model-to-model interaction. She don't just mention that you can use a large model to train small models. In fact, in the future, you can actually, when you try to accomplish a task, you can use a federation of different models, different foundation models from different companies, and from open source, from closed source, and also different vertical models. So those it's another research we're doing. And obviously we have other people doing reinforcement learning, also deploy the large model into edge, to your phones, your robots, and also your IoT devices. In fact, that I see as a huge risk. We talk about that later. When you connect the information world into the physical world, the biological world, there are a lot more safety issues and risks.
Yeah. But even the model interaction, because you want to make sure you always understand what the machines are doing. You don't want to leave it to the machines, because I think maybe many in the audience remember the science fiction book, I think that came out in 1908, called The Machine Stops. Because the machine works so well, human being just decided to leave it to the machine, and over the time, you no longer understand what the machine's doing. But we'll get there later.
Phone number. I don't have a phone number anymore.
Yeah, exactly. We're a calculator. Pascal, you're from research, and you've been a champion on this issue. Because now a lot of the resources when it comes to large language models are concentrated in the industry. How do you make sure that academia has access to the research, to the necessary resources that you need to conduct the research? Can you elaborate on that?
Yeah,
please?
indeed, Kathy. Up until just about 3 years ago, I think academia, research, industry research are quite similar. In fact, we used to know that academic research tend to be longer term. So we will be doing more futuristic kind of research, whereas industry research will be more applied research. But this has sort of flipped with these large models, because I mentioned these models came out during the pandemic, and I think there's a reason why. Because the companies made a lot of money, they have a lot of money to throw at the resources, computing resources, which academic institutions do not have. So since the emergence of these large models, generative models, I remember just about 2 years ago, my PhD students asked me, Pascal, what are we going to do now? Everything you can just prompt GPT-3 at the time. And what is the natural language processing PhD student going to do? We don't have a thesis anymore. But that's actually, no longer true. Because with the emergence of, first of all, GPT-3, then and ChatGPT and so on, we see a lot of problems with these models. Number one, they're not transparent. So not just not transparent to the users, but not even transparent to the researchers. Which means what? Which means that we cannot, as developers of these models, predict what it's going to do, its performance. As I mentioned earlier, we even when we benchmark it, recently Hugging Face did some kind of benchmarking, and they realized when you benchmark it with different prompts, it will give you different results. So it's not transparent, it's not quite controllable, and that is a big challenge, a big technical challenge. So in academia, so among my students, one of the biggest tasks we're tackling right now is how to mitigate model hallucination. So I mentioned earlier, generative models are very powerful in generating content. But because they are generative and they are creative, the flip side of it is that they don't care, well, they don't care, I shouldn't use these terms, but they generate whatever you want them to generate. So it can be factual. Okay, if you just want them to generate beautiful pictures, I also teach a course in design at Central Academy of Fine Art on using AI for design. It can generate creative ideas that we haven't thought about, great. But on the flip side is that when you generate certain things that do not quite fit the physical law, a person with 6 fingers on one hand, or ChatGPT responding to you about some kind of historical event that never took place, right? And many people take it at face value. So like a lot of people, I mean, me included, can be very gullible. So you ask those questions and you get the answers, you have no idea that they're actually wrong. So this is a phenomenon called hallucination. And how to prevent hallucination is a huge technical challenge. So my PhD students are very busy today working on how to mitigate hallucination from different ways. Also working on how to mitigate model bias. They can generate toxic content response, they can generate bias response, and as a reflection of the data they've been trained on. So the imperfect human society is reflected and represented in the imperfect generative models. So we actually have a lot to work on. And to work on these models, to mitigate hallucination and mitigate toxicity and so on, we don't necessarily need to retrain the large model. So we don't necessarily need this huge computing source to retrain these models in order to find solutions. Because in the future, if you think about it, any end user is not going to have the computing source to use it. But we want the end users to have the ability of controlling what they want to see. So this is what we are trying to build, right? In academic institutions, we need to look in the future and look at developing smaller models, more controllable models, and more tools for the end user to control what they can use from the large models. So there's a lot for us to do. On the other hand, coming back to your original question, which is that today, in fact, these large, especially the large language models, are mostly trained from English data because that's the most dominant language on the internet today, by far. Because even non-native speakers will create websites in English, even if they have a website in their own language, there's always English. So the English abilities of these models are way more superior than the abilities of these models in other languages. And we have found that via our benchmarking. And the second to that, I would say the abilities in Chinese language is also, they're also quite impressive because, there's also a lot of Chinese content today on the internet. And the Chinese internet use is very, it's very, very popular. So Chinese users create and consume a lot of internet content in Chinese. And don't forget, it's not just websites, but all the social media use and so on. So there's a lot of Chinese language resource as well. However, even the closest next languages on the internet, Spanish and Indonesian languages, they're actually the next closest popular languages on the internet. We don't have very good language models in those languages. Actually, for Indonesian languages, despite the content in these languages on the internet, there is, it's about ground zero for Indonesian language and natural language processing. I remember when I first started in HKUST at the time, 1997. I remember Chinese language at the time was considered a low resource language. So I worked on Chinese language processing at the time as an underrepresented language. Today, it's no longer the case.
Yeah.
But there are many underrepresented languages still, Indonesian being one. And Indonesia actually has many different languages as well. So there are many, many languages in the world. There are 6,000 languages in the world today. The LLMs are not performing nearly on par with the English language in any of those other languages. So we have a job to do collectively in the public sphere, together with the companies, with the academic institutions, with the government support to enlarge the effort on building generative AI for every community, for every language, and for every economy in the world. So we do not see this increase in the economic divide between the haves and have-nots. Really, the haves and have-nots of AI, it will be more terrible than we can imagine today. So we need to actively work against that by expanding research and development in other languages.
Yeah, well said. So that's when we talk about global access and participation. It's important to, now Chinese as language has caught up, but we need to make sure other languages and cultures are represented as well. I'm going to turn to Minister. Being at the forefront of policymaking in Slovenia and also EU level, what are your thoughts on implementing, the kind of anticipatory governance? Especially now, we're going to have the EU AI Act coming up. It's just passed the Parliament, but it's probably going to take another 2 years to come into effect. What are your thoughts around what are we regulating? Are we regulating the technology or the use cases, applications? What are your thoughts?
So on a national level, we haven't discussed regulation yet because we're very much involved in the European legislation, and that's the AI Act, and also our expectations from the Convention on AI that is being done by the Council of Europe is there as well. So as you mentioned, it takes some time, but yet if we want to regulate something, then it's good to take some time and see what do you want to regulate. Maybe you don't want to make a mistake and then to miss some opportunity, or to do a mistake there, maybe to be so soft on the regulation. So what we are doing right now is we are watching the development of the technology, which is very hard for a government, even for research institutions. We can see that these developments are very fast. So if you want to put it into a legislation, it is even harder. And then try to be as cautious as possible for the possible risks.
Yeah, absolutely. We are going to open up the panel to Q&A session. I already see there are questions. This gentleman here.
Thank you. Hello, I'm Sangudelia Waijia from Ghana. Some quick questions. The first is, you had mentioned something about how in education, you basically you can't use AI that's just going to be mostly right? Because it's critical. And in some applications, if you're going to fly a plane and United Airlines tells you our pilots are safe 90% of the time, you probably wouldn't fly it, right? There are just some fields where we shouldn't take those sorts of risks. We're already using AI in the criminal justice system, and we're seeing how it's amplifying massive biases, right, and creating issues there. So my first question is, are there certain fields where, given the fact that we don't have 100% accuracy, are there certain fields where we should limit the application of AI? Second quick question is around how do you think quantum computing and the advances in quantum computing, what's the impact is going to have on AI? And final question on, in the same way calculators impacted pedagogy, how do you think the way we learn in schools needs to change given AI, right? Do we need to take it out of the classrooms, or do we need to embrace it and reinvent pedagogy? Thank you.
Thank you for the question. For the first one, I think there are certain fields where we have very low tolerance. If anything is wrong, then the side effect could be unacceptable. Any field like that is going to be highly risky if we apply any immature products. For example, like surgery, your example. Education actually is not that critical for daily homework, but for exams, it's a different story. So that's why we offer actually different services with different costs. Like for exams, the cost for every problem is just going to be much, much higher to make sure the accuracy is very strong. For the second question, I don't want to say I'm an expert in quantum computing domain. Probably we have better experts here.
I don't know anything about quantum computing. But I, as an educator, as a professor, and also as a mother of teenage daughters, I actually have a bit of a contrarian view about the impact of AI on education. I believe in the future, as I mentioned earlier, machine intelligence can take over a lot of skills that we possess today, skills. So what we need to train in humans, the future humans, is to be more human. So to have more critical thinking, more humanities. So I advocate for curriculum revival into having more, for example, history, philosophy, ethics, the arts, the creativity side, and as well as mathematics and sciences. So, and I advocate for education system where everybody receives this kind of a holistic curriculum. Today, our education system has been very much divided into silos. Our engineers, for example, I can see very clearly, you ask the engineers developing AI system to figure out human value alignment, it's a huge challenge. Then you ask ethicists to give us feedback on the systems. They do not necessarily understand the algorithms. So in the future, we cannot have this kind of silo anymore. So we need to go back to the basics and teach our younger generation to be really Renaissance men and women, and then go back to the basics. So more humanities, more sciences, more mathematics, and maybe less, I shouldn't say that, but less of the skills that we are trying to teach them today, because those skills will be replaced by machines. So that's my view on the impact of AI on education. And I don't know anything about quantum computing, but I think they're good. And the first question is about which area we shouldn't use AI. I think in every area where we need decision making, we should have humans make the final decision using AI as a tool. So I keep emphasizing this partnership with machines as a tool, and humans making the final decision. So be it medical doctors or tutors and company CEOs. So there's a decision-making step at the end should be made by humans together with the machines as tools.
And I think you answered the calculator question already. This gentleman in the back, and then this gentleman. Sorry.
Well, I'd just like to come in a bit on quantum computing. Yeah, well, I'm not an expert, but IBM is a world leader in quantum computing, and we've been taking various measures. The main area for application of quantum community is, training AI models and also research on medical teaching materials. Now, we think that it could massively shorten the development period for new pharmaceuticals. Thank you.
I believe these models are capable of writing the code as well.
Yes.
And alongside to that, they are capable of building similar such model like themselves, replicating themselves. If the panel could, deliberate a little bit on that and, help us understand the implications of that, especially in the tech industry piece, what does the future of code look like?
Yeah. So the question is implication of Gen AI writing code. Yati, would you like to take it?
I think it's good. Well, the biggest developer of GPT 4.5 or 5 is GPT 4, right? And my son actually works for Microsoft, and he still writes code, but most of his time is to use GPT type of tool. So I think this will certainly enhance the productivity very significantly in the next few years. Not only writing code, but also in terms of being a good architect, designing your infrastructure, your data center. So it is going to. I think so. That's all positive. I think we don't have to use a lot of programmers. In fact, this trend has already started quite a few years ago. If you look at, when I was writing code, we spent time writing code. In the last 10 years, most of the coders, developers, actually using open source. And then they're using some type of automatic tool to help them writing code. So I think this is a good thing. But one risk is when machine starts to write code, it automates the whole process. It will generate things that may not be fully understood, may not be controllable. So that is the worry that the tool actually use other tools. The tool generates other tools. That itself, self-evolving, something that we need to better understand. And that's why we're seeing that we need to make sure that there is a clear boundary between the information world, the physical world, the biological world.
Yeah.
And we know that there are a lot of risks in the information world. Content, copyright, plagiarism, the fakes, misinformation, hallucination. But if we limit the information world, it is a risk, but we have to understand the type of risk, and we can have means to address those. But when it connects to the robots, the drones, or autonomous vehicles, then the things that you cannot explain might not result in things you cannot expect. And also when it connects to critical infrastructure, the banking, core banking, for example, you have to be very careful. In fact, when I advise the companies I work with, there are two types of companies. One is more on the content generation creatives, advertising, create a lot of games. I would encourage them to use as many generative AI as possible. But for companies, the banking or critical business, you got to be very careful. You can still use it to help their productivity. You have to write emails, do summary, and communication. But to do financial transactions or anything that has that nature, you have to be very careful.
Absolutely.
Probably have people.
We're going to take two more questions. This gentleman here, and any questions on this side? Anyone from this side? Okay, good. Then there's one more there, and then, yeah, please.
Yeah, my name is Dinglong Huang from the YGL community. Today, both Professor Zhang and Dr. Wang talk about AI and education. Actually, this afternoon there is another session about education disrupted. It's not about AI, but still people talk a lot about AI. And on that session, I share a recent case. It's in China, in Shenzhen. Some junior school student, they use AI to design a beach park. Their work are quite fantastic. Even people see their work and will feel this should be generated by the graduate student. But actually it's generated by just several 10 years old kids. So, but people have different opinion about this. Some will say, oh, it is cool, because it seems like our students don't need to spend so long time to learn so much knowledge to generate a professional work. But another opinion will feel, okay, this is unfair, even somewhat dangerous. So firstly, I have one question for Professor Zhang. So as a Tsinghua professor, suppose Tsinghua student want to use AI in their study. They use AI to do their homework, or even use study to do their research, to write their paper. What will be your suggestion? And I also have a question.
Sorry, we are running out of time. We can keep it to one question, and sorry about that. Maybe we get that question as well, and then we let the panelists answer them collectively.
Great, thank you. Hi, Brian Wong, also YGL. My question is to the panel. Where do you all see the biggest bottlenecks in the development of AI moving forward? Is it in the cost of electricity, the cost of compute, the access to data, and how will this impact this and the geopolitical situation, particularly the export controls U.S. to China, how will this impact China's development in the AI sector?
So for the first question, going to go to Yaqin.
Yeah, I love it. I encourage all my students to use, whatever AI tools that's available. But they have to tell me if this is the help to use GPT-4 or whatever. They have to tell me. Same thing is for any synthetic contents. It has to be a clear donation. This is from AI, right? Or if it's a bot, but a digital person, we have to know it is digital. So I think that is probably the first policy and law that we should make. And in the future, education obviously is about to learn knowledge, but it's also about how to learn the tools like AI. So I think our kids right now, when they go to kindergarten, they need to start to understand those tools, just like a computer, just like the PowerPoint. But this is more powerful, but in principle not that different. It's just new tools that will enable us, empower us.
Yeah. So unfortunately, we did run out of time, and we are a Swiss organization, very proud of being on time. So just wanted to mention one thing, that the forum, we launched the AI Governance Alliance just a couple of weeks ago, with the aim to champion the responsible global design and development and also deployment of responsible AI, with a current focus on generative AI. So we really hope to work with all of you from industry, government, civil society, academia, to really pave the sustainable and also inclusive pathway for the futures of AI. So please do get in touch. And finally, really just a big round of applause to all of our panelists today. Thank you very much. And thank you. And hope you enjoy the rest of your time here in Tianjin. Thank you.